What if I told you that one of the most important materials in our modern world is hiding right under your nose? I'm talking about in your wallet, inside your walls, and even helping to save lives in hospitals. Today, we're going to pull back the curtain on PVC, the plastic that is, quite literally, everywhere. Okay, so let's just jump right in with a little bit of a puzzle. Think about the credit card in your wallet. Thin, flexible, precise. Now picture the huge, heavy-duty pipes buried under our cities, carrying water for miles. I mean, they couldn't be more different, right? So what on earth could they possibly have in common? Well, believe it or not, the answer is a single, incredible material, polyvinyl chloride. You probably know it as PVC. It's this amazing chemical chameleon that gives both of those things their totally unique and absolutely essential properties. So for our first section, let's dig into how this one plastic became such an invisible giant, something that's truly hiding in plain sight all around us, every single day. The thing is, PVC's takeover was no accident. This stuff is a real powerhouse. It's tough enough to last for decades, it shrugs off chemicals, and it's really cheap to make. But its real superpower? It's that adaptability. It's like a material chameleon. It can change its form and its properties to fit almost any job you can think of. That adaptability is it's amazing. But it begs the question, right? Where does this super plastic actually come from? Let's take a look at the recipe. It all starts with two really basic building blocks, chlorine from salt and ethylene from natural gas. You combine them to create a new molecule, something called a vinyl chloride monomer, or VCM for short. Now here comes the magic step. Thousands and thousands of these tiny VCM molecules are linked together into these incredibly long chains, and the result? It's a simple, fine white powder called PVC resin. Now, this whole process has a technical name, polymerization. It sounds complicated, I know, but the idea is actually super simple. Imagine each one of those VCM molecules is a single paperclip. Well, polymerization is just the act of linking thousands of those paperclips together to form a long, strong chain. In the factories, they do this in a really clever way. They suspend tiny droplets of VCM in water, and each little droplet acts like its own tiny reaction vessel, its own miniature factory. But here's where it gets really interesting. That white powder? It's just a starting point. It's kind of like flour for a baker. To unlock PVC's true potential, manufacturers mix in a secret recipe of chemical additives. You see, on its own, pure PVC resin is actually pretty brittle. You could probably snap it pretty easily. But by mixing in special additives like stabilizers that protect it from sunlight or something called plasticizers that make it flexible, chemists can give it all these different superpowers, transforming it into wildly different materials. And this right here perfectly shows off the two main personalities of PVC. If you leave out those plasticizers, you get what's called rigid PVC, or UPVC. That's the strong, tough, structural stuff used for pipes and window frames. But add those plasticizers in, and you get flexible PVC, the soft, pliable material that's perfect for things like cable insulation or medical IV bags. It's one base powder, creating two completely different worlds of material. So with these two personalities in mind, let's take a look at how PVC became the true unsung workhorse of the modern world. One of PVC's most important kind of built-in features is its natural fire resistance. Thanks to all that chlorine in its chemical makeup, it actually tends to self-extinguish. So once you take the flame away, it often just stops burning on its own. And you can imagine that is a huge safety advantage, especially for materials we use inside our walls or around our electronics. When you look at construction, PVC is absolutely foundational. I mean, we're talking about water pipes that are designed to last for over 100 years. We're talking about energy-efficient window frames that you never have to paint, and the insulation that keeps all of our electrical wiring safe. It's literally in the bones of our homes and our cities. And its role in healthcare? Well, it's just as critical. Because it can be made so clear and flexible and it's easy to sterilize, PVC is essential for life-saving devices, things like blood bags, all that flexible tubing, and oxygen masks. And of course, it's just woven into the fabric of our daily lives. From the credit card that kicked this whole thing off, to the dashboard in your car, your garden hose, even vinyl records, PVC is the silent partner in so much of what we see and do. Okay, but with a material this common, this widespread, you have to ask the question, what's the life cycle look like? So let's get into PVC's environmental story. So what happens when these PVC products reach the end of their useful life? Well, while some of it does end up in landfills, that's really only a small piece of the puzzle. As you can see, a huge portion is actually recycled or reused, giving the material a whole second act. The most common method here is mechanical recycling. That's where rigid PVC from old window frames and pipes is collected, ground up into little pellets, and then reprocessed into brand new products. And you have to remember, its incredible durability is a sustainability feature all by itself. A pipe that lasts 100 years doesn't need to be replaced very often, and that saves a massive amount of resources over its lifetime. So, there you have it. We've seen how this hidden material is made, how it's used all around us, and how it gets a second chance at life. For decades, PVC has adapted to meet our needs. I guess the big question we're left with is, as our world faces new and different challenges, how will this endlessly adaptable plastic continue to evolve right along with us?